Hello students, welcome back to Chemical Kinetics. In this module, we are going to understand some more factors which affect rate of reaction. Basically, there's just one that's remaining, a catalyst. We have already seen some other factors which affect rate of reaction. So this brings us to the third part. We have already seen that the factors affecting rate of any chemical reaction are concentration or pressure. Concentration is for solutions, pressure is for gases. Also, we've got temperature, which affects the rate of reaction. In the last video, we saw how nature of reactants, whether the reactants are powdered or whether they are solids or liquids or gases, how all these factors affect rate of reaction. And we saw that how light affects the rate of photochemical reactions. In this module, we are going to study how catalyst affects the rate of reaction. Now, before we understand how a catalyst affects the rate of reaction, before we understand the effect of catalyst, we need to understand what exactly is a catalyst. So, in order to understand what exactly is a catalyst, whoa, is that a wedding going on here? And we were not invited. Nevertheless, if you take a look at this example right here, you will understand what is a catalyst. Look at the bride and the groom. They are all so happy for the special occasion. But these bride and groom are like the reactants. They are undergoing this particular reaction right now. So let's ignore them for a second and focus on this guy right here, the priest, the minister who is carrying out this reaction. There are two things about him that you must note. Number one, that he remains unchanged at the end of the reaction. At the end of the reaction, he is the one who will remain unchanged. Also, he has a critical role in deciding how fast this reaction will take place. That is exactly what a catalyst does. A catalyst is a substance which alters the rate of reaction, but it is found to be chemically unchanged at the end of the reaction. That is what a catalyst is. If you take a closer look at what a catalyst really does, it's this. You can see two guys who want to go from the start point to the finishing point. One of them takes a longer route. What he's doing is he's trying to climb up a mountain after he has gained sufficient potential energy. The reaction will become spontaneous. If you recollect, it reminds you somehow of activation energy. After a certain point, when activation energy has been taken, the reaction becomes spontaneous. That is what we know from thermodynamics. But the second guy down here, the smarter fellow, what he's doing is he is going through a tunnel which doesn't require that much activation energy. So the energy required for the second path is not as much as the first one. That is exactly what a catalyst does. It provides an alternate path of lower activation energy. I'm sure you remember this graph, energy versus time. We did this graph in thermodynamics. Energy of reactants and energy of products in a reaction with time. When the reaction begins, the reactants absorb some energy, activation energy. This activation energy activates the reaction. So there you go, the reactants absorb some energy. The reaction becomes spontaneous and then it goes on its own. If you see this difference between the energy level of the reactants and the energy level of the activated complex, this difference is called as activation energy, but this is without any catalyst. What a catalyst does is it lowers the activation energy. So now this smaller activation energy is the one which is required in presence of a catalyst. This will be the alternate pathway now. So that's your activation energy with a catalyst, a smaller value. That's what a catalyst does. It provides an alternate pathway of lower activation energy. And that's how it increases the rate of reaction. Because now the energy required for the reaction to become spontaneous is less. That is the effect of a catalyst on the rate of reaction. That's all for this module. With this, we have finished the different factors which affect the rate of reaction. In the next module, we will see two very important laws related to chemical kinetics. Till then, thank you.